Hey guys, it is like 5:20 in the morning and I'm recording this and I'm very tired and there's no lights on and everyone's sleeping, so I gotta keep it a little quiet. But we are gonna start looking now at three-dimensional figures. So now, instead of just geometry on a flat surface with two-dimensional figures, we're gonna look at three-dimensional. So, something like this. This is the entrance to the Rock and Roll Hall of Fame, and it's shaped like a pyramid, which is a three-dimensional figure. So there are a lot of them. Obviously, we live in a three-dimensional world. And we see these all over, so we're going to learn a little bit. Just kind of like learning some names and stuff like that for some of these objects in this section. And we're on 435 in your book, so if you guys want to go to page 435, page 435. That's where you want to be for your notes. So first of all of these objects, we call them polyhedron. It's a three-dimensional figure or a solid with flat surfaces that are polygons. A polygon, if you guys don't know what a polygon is, it is an object made of straight lines, all connected. Okay, and that's a two-dimensional object. But when you put a bunch of polygons together in 3D, those are called polyhedron. So prisms, these are examples of prisms, and then pyramids are examples of polyhedra. Polyhedra is plural for polyhedron. A prism is a three-dimensional figure with at least two congruent parallel faces called bases that are polygons. So for instance, this, if you see at the ends, there's two triangles at each end that are congruent and parallel to each other. Those are called the bases. And then here we actually have multiple sides of parallel bases. So it says at least two congruent parallel bases, and that's what makes it a prism. Prisms are named by the shape of their base. So these bases are rectangles, so we call it a rectangular prism. These are triangles, so we call it a triangular prism. A pyramid is named by the shape of its base. So a pyramid has one base and then sides that are triangles. Again, each side we call a face, and then we would call this, since the base is a rectangular pyramid, this base has a triangle, so it's a triangular pyramid. Now, you should also be able to identify faces, edges, and vertices of a triangle, or polyhedron. An edge is the line segment, so CD, and we name it with a little line segment on top. It's the edge where two faces of the polyhedron meet. So notice where this side and this side meet, we have an edge. And then a face is a flat surface. It'll be a shape like a rectangle, a triangle. And then a vertex is just a kind of a corner point where three or more faces meet. So notice here, this side, and the bottom would all meet at that point. Vertices is the plural of vertex. Now there's also three-dimensional figures we're going to look at that are not polyhedra. So a cylinder, this is a cylinder. It's a three-dimensional figure that has two parallel and congruent circular bases. So it has bases that are circles connected by a curved surface. And a cone has a circular base also connected by a curved side to a single point called an apex. A cylinder has two parallel bases and they are congruent and circles. This one has one circular base. So you should know and be able to identify what all of those are. So first of all, we're going to look at some of these things. Is this a polyhedron? Yes, it is. The shape of the base is a polygon, in this case a hexagon, and it has at least two congruent parallel faces, flat surfaces that are polygons. This one is a pyramid. It's a polyhedron. The base is a rectangle. It has one base, and the flat sides are surfaces. This one is a prism and a pyramid. Interesting. Okay, so we can look now. Oh, there you go. A cone. There's a pyramid, here's a cylinder. So here you can read again about some of these figures again. Okay, so now if you guys want to go to page 436, you really just have to be able to identify a few things about each of these, not a ton of things. So just count how many faces, edges, and vertices each of these has. So if we want to count the number of faces, that's how many sides. So it kind of highlights in green for us. There's one, this bottom one. It's just going on its own. So let's count, starting now. 1, 2, 3, 4, 5, 6 faces. So it kind of shows you, that's kind of cool. And then, let's see. We have to put down here. No, okay. Now the number of edges. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Go back and pause, or go back if you missed all those, but it kind of shows you in orange. There are 12 edges for this one. And then vertices, count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. So that's what we're looking for. Hopefully you can see what is an edge, what is a vertex, what is a face, and be able to identify each of those things. So that's not so horrible. It is kind of hard to picture things in 3D, but that's really all you're doing is just identifying how many of each of those there are. And on page 436, each of them are named for you. So if you look at 436, it names all the edges and the vertices. So the other thing you need to know is describing the cross-section of three-dimensional figures. This is a little tricky, but just look at this video really quick.
Cross-sections of 3D figures. Describe the two-dimensional shape resulting from a cross-section of a sphere. Make a slice through the sphere. This is called a cross-section. The sphere may be sliced horizontally, vertically, or diagonally. The two-dimensional shape resulting from the cross-section of the sphere is a circle. Describe the two-dimensional shape resulting from a cross-section of a cube. Slice a cube horizontally. The result is a square. Slice a cube vertically. The result is a square. Slice a cube diagonally. The result is a rectangle. Describe the two-dimensional shape resulting from a cross-section of a cylinder. Slice a cylinder horizontally. The result is a circle. Slice a cylinder vertically. The result is a rectangle. Slice a cylinder diagonally. The result is an oval.
Okay, so cross-section is just if you were to slice an object, a three-dimensional object with a plane, you can see that it's like an oval shape instead of a perfect circle there. So again, this, you don't have to be perfect at it, but we're just going to try to start thinking in 3D and seeing if we can visualize things in 3D. So think about it. If I took a square pyramid and I want a horizontal cross-section, so meaning I cut it horizontally just straight across that way, or vertically straight down, or at an angle, what would each of those look like? And we're going to look at some examples here. So think about this. If we, here, I have to drag it. Ooh, look at that. If I slice it that way, what shape do you see there? That one is a triangle, right? Can you see the triangle over there? If I slice it horizontally, what shape do you see? Oops, I gotta return it. Okay. Now, if I drag it this way, then you see a square. And if we drag it this way, what do you see? Can you see that it's not quite a square? What do we call that? It is a not a rectangle, but a trapezoid. So again, this is nice because it kind of shows you, but you're just kind of giving a picture, just an idea in your head. If you don't get them all, it's fine, but at least to start thinking in 3D and kind of thinking of what that cross-section would look like. Here's another example on 438. And actually, see if you can try the check at the top of page 438, see if you can figure out what that one is. And there's also a check problem on page 436 and one at the bottom of page 438 as well. So let's look at one more example. Here, if we were to find a cross-section for this shape, so here, if you see a cross-section, it's I would say more of a rectangle than a square, right? And then if we find a cross-section this way, also, what shape do you see? I see a rectangle. And if we were to slice it this way, that's interesting, but what shape do you see? This also does look like a rectangle. So in this case, a rectangular prism, they're vertical, rectangular, and rectangular slanted. And they all end up being rectangular rectangles. So that's pretty much it. So try all those check problems. Try the check problems and get a parent to sign it. And that is all for this lesson. Talk to you later, guys.